In this video we are going to explore notches within ZebraCut, how to detect them and how to place them. So first of all, what is a notch? Well, a notch is a pen mark or a cut mark which is used to help align pieces during manufacturing. The simplest kind of notch would be a line notch. In this square we are placing a notch at this point here. And you can see we have a line internal to the part, which is our notch. Genuinely, you would find that on two different pieces you'd have notches which would need to be aligned during manufacturing. The advantage of a line notch is that if you cut it, you can see it from both sides. Of course, you can just pen mark it, but then it's only visible from one side. Now there are various types of notch, each with various disadvantages and advantages. For example, you can see here is a T-notch, slightly slower to cut, but it will be easier to find the end of the notch, and you'll start to get a tear that continues into your piece of material. You may also come across a circular notch. These will be slightly faster to cut, but maybe less accurate to align. So it's always a trade-off with these things. So those are three basic kinds of notches. You'll also find V-notches, which actually take a chunk out of your material, and you can see this is now part of the perimeter of your shape. Again, the notch has been placed at a particular point, and I've left the point mark in there so you can see where this notch is actually placed on your shape. Other kinds of notch would include square notches, again perhaps easier to line up, but again slightly slower to cut. Or indeed arc notches, which would be much faster to cut but perhaps less accurate to align. In addition to notches, we also have tabs, and so you can see there is a V tab, a square tab and an arc tab which correspond to their notches. So these are the 9 types of notch or tab that ZebraCut supports. We support detecting these, we also support placing these. So let us have a look in a real example. So I have here a garment in multiple pieces, and in order to be able to sew these garments together, we need to make sure that we have the alignment marks. And if you zoom into this file, you can see there are all sorts of little notches being placed around these pieces so that they can be sewn together accurately. Now, one of the challenges in this file is you'll see there are multiple types of notch. So we have some very standard line notches being placed. We also have some V notches, and you'll notice these V notches are not actually part of the outer contour, so they're just kind of extra geometry. We can also see there are some square tabs in here as well. And of course you can place multiple types of notch and cut them as you wish with ZebraCut. But for the purposes of the exercise, what we want to do is we want to try and make these more uniform in our file, make it easier for the manufacturing of this garment. So let's try and detect these notches. Before I do that, I need to make sure that everything is joined. So I'm just going to select my geometry, and I'm in selection mode for preparation, and I'm going to run a join geometry preparation step. So if I just hit join, you'll see that we now have closed outer contours for each of our shapes, and we can now have a look at the notch detection preparation step. Now there are a lot of options for this, but that's to allow you to be able to detect just the notches you want. The most important option here is the detection type. So you can choose to select all of the different types of notches that ZebraCut supports, or you can also just select the one you're particularly interested to find. Perhaps you want to remove V notches or V tabs, for example. But for this, we're going to go through and we're going to run and we're going to just do all of them. Then we need to be quite specific with our sizes, so we can use Rhino's tools for measuring. So if we go to Analyze, Distance, we can then measure the length of this notch, and it's just under 3 millimeters. So I'm going to detect notches between, let's say, 2.5 and 5 millimeters. That is the distance into the material. Often I also have to specify the width of the notch. So this notch here has a particular size opening, and I'm just going to go between 2.5 and 10 millimeters. So that gives ZebraCut a good idea of what to look for. And now we need to decide what we're going to do once we've found it. Now I want to remove the notches because I'm going to put them back in again using ZebraCut in a few moments, but you can choose to either do nothing with them or move them to another layer. Perhaps you want to use a different tool for notches. Clearly you need to specify the layer name if you're going to move them to a different layer. You can also choose whether or not to repair the shape. So for example, if I find one of these tabs that we were looking at earlier on, if I was to repair the shape after moving this notch to a different layer, I would then place a line directly across the bottom of that tab so that the outer contour remains continuous. So this repair is a really important option. But what I really want to do in this tutorial is to place a point at our notch so that we can then use that for placing different kinds of notches. So these are the options we're going to run with. You can also tell ZebraCut various tolerances to use. Generally you'll find the defaults are correct, but you do have the ability to change those if you need to. So let us run our notch detector on our parts here. So I'm just going to run these parts and then run our notch detector. So we have now got a series of points placed around our notches, and you'll see our notches have disappeared. So we've now got points on the perimeter of each of our parts, and we can see that all of our notches have been removed. Indeed, they've been repaired where that tab was, for example. So that's notch detection. We found 189 different notches across this file, and we have no false positives either. For example, this little step here could be found as a V-notch. It looks like a V-notch, but we actually have some advanced algorithms within ZebraCut which will make sure we do not find false positives. So that is notch detection. I'm also going to show you that running on nested parts, because ZebraCut is able to deal with nested parts and intelligently choose what is a tab and what is a notch. So to do that, I'm going to work on these two parts here, and I'm going to just try to find only, let's have a look at V tabs. So if I run that, you'll see it's only found the V tabs. If I just undo that for a moment, and in this case not delete the tabs, what you'll find here is we can then see actually what's left. So it's found two different tabs, and because this part has an inner hole, an inner contour, you'll see what might look like a notch in this square is actually a tab, because this is the inner contour of my part. Correspondingly, I can also then do that on just V notches as well. So in this case, if I run that, you'll see I just get the two notches. But again, if you were to consider this shape individually, you might think that is actually a tab. But ZebraCut is intelligent to do with your nesting, and you can nest through multiple layers as deep as you want, and ZebraCut will allow you to flip between notch detection and tab detection appropriately based on what you specified. So we can do notch detection within nested parts as much as required. Okay, so that is notch detection. Let us now have a look at notch placement. So within ZebraCut we have a Notch Creator preparation step, and the options are broadly similar to what we have in the detection as well. Now ZebraCut, in order to place notches, needs points. So we need to have points placed directly on the outer contour of our parts. Our parts need to be closed contours. And we need to have points placed directly on them. Now that is exactly what the notch detector will give you, but if you're bringing in notches from other software, you need to bring them in as points in your files. So the notch detector has a number of options. Firstly, we're going to look at what layer to convert. Maybe your notches are in a particular layer. In this case, we're just going to try and convert any layer, so just going to star there. We then want to decide what kind of notch we want to place, and I'm going to deal with arc notches for this case. We're then going to specify the size of these notches, so we're going to have them quite small, so perhaps just 7mm wide and 7mm deep. You can also specify a minimum opening, which we'll come to in a moment. It's just a sanity check to ensure that ZebraCut has created a big enough notch for your manufacturing process. So we're going to have, let's say, 3mm as a minimum size for our notches. I do want to splice these into the part, so I want to make them part of the perimeter wherever it's possible. I'm not going to delete the points, but clearly I could, and I could also put them onto a new layer if I wish to, and give that layer a name. So if I wanted to leave my external contours and have all of my leave my external contours as is, and have all of my notches on a separate layer, I can do that by choosing Place on New Layer, not choosing to splice, and just entering the name of my layer. Clearly I need to provide some tolerances as well. If any of these options are perplexing, there is help here at the bottom which will talk you through what these lengths mean. So let us run this step here. We'll select our geometry again and we'll just hit apply. And you'll see now if we zoom in, wherever there is a point, you'll see there is now an arc notch that we specified. So all around our geometry we now have these arc notches placed correctly, and you'll see even on corners we get arc notches. This is actually now more than 180 degrees of a circle, but that is correct and to enable you to then be able to sew these garments together. Now if I undo that, I can use a different kind of notch, so perhaps let's just have a look at a T-notch for example. And let's try and make this slightly more of a T, so we'll have 7mm into the material, and an opening, in this case the T-bar will be 4mm. So again, I will just select the geometry I want to run. I'm in selection mode, so I just press apply. So there we go, we've now got our T-notches placed correctly around our geometry. Now it is also possible to achieve this process using a cam step, that is the placement of our notches automatically based on the points. To do that we're going to go to Advanced, to our cam pipeline, and we're going to make sure that we have a notch creator step within our pipeline. If we don't, we can add it from the list here and add notch creator as a step in our cam pipeline. Once that's done, I can then go to the job configuration and I can make sure that I have a notch creation configuration in my job config, and I have all the same options as I did in the preparation step, but now as part of the job configuration. What that allows me to do is to keep my geometry, my design clean. I just have points, and I can see those points are very visible. And then when it comes to actually being the job being previewed or run or sent to the machine, then I get the notches created almost at runtime. So let us just do that now. I'm going to select sure I've got my geometry selected. I'm going to assign some layers to this. So I'm just going to use pen marking for this one, and I'm not going to cut my guide layer, or indeed that layer there. That should then allow me to go through and preview this, and this will go through and create line notches which are 10mm long and opening of 3mm. So if I run that, we should get a preview. I'm just going to run again in selected mode, and we should get a preview which contains our notches. So there we go. You can see we have our G-code preview layer, and that contains our notches, but our actual geometry has remained unchanged. So that means if I want to try and swap to a different kind of notch, I can now do that by changing, let's say, to a T-notch, and if I preview again, then I need to select some geometry. Let me do that. Select some geometry, and now if I zoom in, I should have T-notches. Let me see, what did I do wrong? Clear, select, T-notches selected, and now we can preview. There we go, got the selection this time. So now you can see our T-notches are now in place. Let us just try one final type of notch. So if I clear layers, select my geometry, I'm just going to change here to, let's say, a square notch, and I'm just going to make it slightly larger, so let's make it 12 by 12. And if I now preview this, you'll see I have a large number of square notches placed in my material, including on the contours there, on the corners there. So there we go, that is notches. Again, if I clear layers, all of the notches are deleted and I'm just left with my clean geometry which I can work with much more easily. So that's notches in ZebraCut. Please do ask us if you have any questions. We would love to hear from you soon. Thank you very much.